Okay, now that we are familiar with this new function called logarithm, and we also know some of its properties, let's look at the graph of the function. As we have seen before, the graph of a function is an essential information that we want from a function. Now recall how we can get the plot of the inverse function from the plot of the function, right? So the idea there is that if this is, say, your function f of x, right, then what really is the inverse is you are interchanging x and y, which means if you take the line y equals x and you make a reflection of this blue curve on that, along that, right, so you reflect. When you reflect, you're essentially interchanging your x and y values. By interchanging your x and y values, you're interchanging the input and the output. And by interchanging the input and the output, you are creating the graph of the inverse function from the graph of the function. Which means that if I know what an exponential function looks like in general, right? An exponential function in general looks like that. And therefore, a logarithmic function in general would look like the reflection of this, which is that particular shape. Where this point on the exponential function is 0, 1, so this point is 1, 0. Which again makes sense because the fact that 0, 1 is a point in the exponential function is basically saying that any number raised to power 0 is 1. And 1, 0 being the intercept here means that log of the number 1 is always 0. And let's use these to plot these two functions. So here we're going to start with log base 2x and then we make it negative. Making it negative, what it does is it makes all the positive inputs negative and the negative inputs positive. Which means we flip it on the x-axis. So this is going to go up and this is going to go down. Whereas in the second case, what we are doing is we are taking log x and we are replacing x by negative x. So in that case, we are going to be reflecting it along the y-axis. Okay, so this is x-axis reflection and this is y-axis reflection. So which means that we essentially can draw the graph of any logarithmic function now. Now, just as with exponentials, we had a special case with e, it being the special number. We have two different cases for logarithms. If the base is 10, which is our most fundamental counting number, like 10 fingers, we have a decimal system and all of that, the logarithm is called a common logarithm. For example, one of the uses of this is in the perception of loudness. So how do we measure loudness of a sound, And you would have seen this unit called decibels when you select a speaker, right? So what is that? This measured, it's a log scale. So it basically measures the physical intensity of the sound, and it's given by this formula. It's 10 log I over I0. Where what is I0? It is defined as the physical intensity of a barely audible sound. So like something even fainter than the whisper. Okay, so that's a constant, like for a human ear. And then we take I over I naught and the log of that multiply by 10, and that's called whatever we get is called the loudness, which is measured in decibel. So let's do this problem. It says, find the decibel level of a sound whose physical intensity I is 100 times that of I naught. So which means I is 100 I naught. So the intensity is 10 log 100 I naught over I naught. That becomes 10 log 10 squared. Now, because we're working with common log, so if you are given no base, right? No base means it's automatically base 10. So this is 10 times log base 10 10 squared. Now these are FF inverse. So I'm just going to get this power back. This is going to be 10 times 2, which is 20. And we write that as decibel as small d capital B. So essentially what this is telling us is that even when the intensity becomes 100 times, right, that makes it a 20 decibel sound. So one example of this of the what is called the log scale is, for example, if you take two speakers which are identical and you play the same music, you connect them somehow and you play the same music through them, it's not going to sound twice as loud. Yeah, because they don't add up. Sound doesn't add up linearly, right? So if you hear just one speaker and you put two, it's not going to be exactly double as loud. It'll be much less than that. And because of the way log scale works, to get double, you would have to get 10 such speakers. Okay, so that's how sound works. That's one example. The second one is, of course, with the number e. If the base is e, then we write that as ln, which means natural logarithm. So if you ever see ln written, then you understand that it just means it is log with a base of e. Find the domain of this function. Okay, so we haven't talked about domain yet, right? So I just wanted to wait for this example. We say that log, right, this is always positive. Well, if you look at the graph up here, right, you see the domain is always positive. So if you're finding the domain of log of 4 minus x squared, what you need is that 4 minus x squared is always positive. Now this is 2 minus x, 2 plus x positive, and we have recently learned how to solve these kind of inequalities. So you find these points, you take test points, plug in the test point, so negative 3 or 2 minus negative 3, 2 minus 3. That's going to be negative. 0 minus or 2 minus 0, 2 plus 0 is positive. 2 minus 3 and 2 plus 3 is negative. So for this to be positive, you need the values to be exactly between negative 2 and 2. And this is going to be the domain. Now, we will not include negative 2 and 2 because log of 0 is not defined. Okay, and you can see that from the graph is that the y-axis for the log function is a vertical asymptote. So it never approaches that. We can never have an output for 0. Which is another way of saying that if you take an exponential function, then you can never have an output of 0. Right? Because over there, exponential function has a horizontal asymptote. Find the inverse of the function log of x. Okay, so this is now we know that the inverse of a log function is an exponential function. And we also know that what is finding an inverse function, the process for that is replacing x by y and solving, right? So let's start. The first step is log of x. Now we replace or interchange x and y. Interchange x and y. So this gives x is log of y. Okay, now to get rid of the first log, I am going to get an exponent. Now because this is an ln, the base is e. So this is going to be e to the x becomes the remaining logs, log of x. Now I want to get rid of this log, so I take an exponent again. So now I get e to the x becomes the remaining, which is log of x. Sorry, this is all y, right? Because we have replaced x and y. So this is y, and this is y. And then the last log, again, when we replace it, this is going to become e to the y, which is x. Oh, sorry. This is y. That was the mistake. This is y, and these are all x's. Okay, so the inverse function is e to the x, which kind of makes sense because what you're doing here is you're composing log 3 times, and here you're composing the exponential function 3 times, so they are inverses of each other. Let's look at another example. It says, find the inverse of this function. What is the domain of this inverse? Now, the process for finding inverse is always, you start with y equals what is given, then you interchange x and y, right? After you interchange x and y, you get a new equation. And now in this equation, you're going to try and solve for y. Now the first step here is going to be cross multiply. When we cross multiply, we can imagine x as being just x over 1 if it helps to visualize as a fraction. So it's x times 1 plus 2 to the y is 2 to the y. FOIL this out. That's x times 1 is x, and then you have x times 2 to the y is 2 to the y. That gives you x is 2 to the y minus x times 2 to the y. You can factor out a 2 to the y, and this is 1 minus x. So you get x over 1 minus x is 2 to the y. Now we are not yet done because eventually we want to get to y equals some sort of thing on the right side. Now here we are at 2 to the y equals some kind of thing on the left side, which means in order to get rid of this, I can take log base 2 on either side. When I do that, I get log base 2 of x over 1 minus x, log base 2 of 2 to the y. Now that is back to being y. And this is log base 2 x over 1 minus x. So this is going to be our inverse function. Okay, that's essentially how that is going to work. Okay, so essentially wherever you have an exponential form, if you take log, they cancel out. And wherever you have a log form, like right here, you can cancel it out by taking an exponential form. Now the last bit that we have to do is properties of log and a change of base formula. So that's going to be in the next video. That's it for this video. Thank you.